Water pipe bonding is required by the National Electrical Code to establish a reliable electrical path between the metal water piping system and the electrical system of a building. This ensures that any electrical fault or surge that occurs in the electrical system will be safely discharged through the water piping system, which acts as a low-resistance grounding electrode. To meet the requirements of NEC 250.4, 8.3 or 4, the water pipe bonding jumper must firstly be sized according to NEC 250.66. This ensures that the jumper has sufficient capacity to carry the fault current. Secondly, be run to the service equipment and or grounding electrode system. This ensures that the electrical fault or surge is properly discharged to the grounding electrode system. Other piping systems, such as gas and fuel gas piping, do not require stringent bonding requirements because they are not typically used as grounding electrodes. Water piping systems, on the other hand, are typically metal and are extensively interconnected throughout a building, making them a reliable grounding electrode. The sizing of the water bond and the grounding electrode system should be coordinated to ensure that the fault current can be safely discharged. A single number 6 American wire gauge grounding electrode conductor connected to 2 ground rods may not provide sufficient capacity for a 200 amps arm. In such cases, additional grounding electrodes or a larger grounding electrode conductor may be required. The NEC provides specific guidelines for sizing the grounding electrode system in NEC Article 250.56, based on the calculated maximum fault current and the available grounding electrodes. Let's delve deeper into the specifics of water pipe bonding, its significance, and how it aligns with the National Electrical Code. The fundamental reason for water pipe bonding lies in electrical safety. Metal water pipes, especially those extensively interconnected throughout a building, can inadvertently become energized due to electrical faults. This poses a significant shock hazard to anyone who might come into contact with these pipes. Bonding the water pipes to the electrical grounding system creates a low impedance path for fault current to flow back to the source, tripping the circuit breaker or fuse and energizing the circuit. Without proper bonding, the fault current could flow through a person who touches the pipe, resulting in severe electrical shock or even electrocution. Now let's move into NEC requirements, specifically section 250.4, A3 and 250.4, A4. These sections of the NEC mandate the bonding of metal water piping systems to the electrical grounding system. The intent is to create an electrically continuous and effective ground fault current path. This path must be capable of safely carrying the maximum fault current likely to be imposed on it. Section 250.4. A3 focuses on grounding of electrical equipment, ensuring that all exposed metal parts of electrical equipment are grounded to minimize the risk of electric shock. Section 250.4. A4 deals with the grounding of non-electrical metal parts, including metal water piping systems, to prevent them from becoming energized and posing a hazard. To meet the requirements outlined in these sections, the NEC specifies that the water pipe bonding jumper must adhere to certain criteria. Firstly, size the bonding jumper according to NEC 250.66. Section 250.66 provides a table that dictates the minimum size of the grounding electrode conductor, including the water pipe bonding jumper, based on the size of the service entrance conductors. The larger the service entrance conductors, the larger the bonding jumper must be. This ensures that the jumper has sufficient ampacity or current carrying capacity to safely handle the maximum fault current. Secondly, run the bonding jumper to the service equipment and or grounding electrode system. The bonding jumper must connect the metal water piping system to either the service equipment enclosure, such as the main panel board, or to the grounding electrode system, which typically consists of ground rods, ground plates, or other approved grounding electrodes. This connection ensures that any fault current flowing through the water pipes will be safely directed back to the source and to ground, tripping the overcurrent protective device and clearing the fault. You may ask, why is water pipe bonding more stringent than other piping systems? Other piping systems, such as gas and fuel gas piping, are not typically used as grounding electrodes and therefore do not require as stringent bonding requirements. Gas pipes, for instance, are usually made of non-conductive materials like plastic or coated steel, which do not readily conduct electricity. Furthermore, gas piping systems are designed to minimize the risk of electrical contact. Water piping systems, on the other hand, are typically made of metal, such as copper or steel, and are extensively interconnected throughout a building. This makes them an ideal grounding electrode, but it also necessitates proper bonding to ensure electrical safety. Now let's explore the coordination between water bond sizing and the grounding electrode system. The sizing of the water bond and the grounding electrode system must be carefully coordinated to ensure that the fault current can be safely discharged. The grounding electrode system, which includes ground rods, ground plates, and other grounding electrodes, must have a sufficiently low impedance to ground to effectively dissipate fault current. The water pipe bonding jumper, sized according to 250.66, plays a crucial role in connecting the water piping system to this grounding electrode system. Now let's examine a scenario. A single number 6 American wire gauge grounding electrode conductor connected to 2 ground rods may not provide sufficient capacity for a 200 amps home. In such cases, additional grounding electrodes or a larger grounding electrode conductor may be required to ensure that the grounding system can effectively handle the maximum fault current. The NEC provides specific guidelines for sizing the grounding electrode system in NEC Article 250.53 and 250.56, based on factors such as the size of the service entrance conductors, the type of grounding electrodes used, and the soil resistivity. These guidelines help ensure that the grounding system has a sufficiently low impedance to ground, allowing it to effectively dissipate fault current and protect against electrical shock hazards. Here is a summary about water pipe bonding and electrical safety. Water pipe bonding is a critical safety measure required by the NEC to protect against electrical shock hazards. By creating a low impedance path for fault current to flow back to the source, water pipe bonding helps to trip over current protective devices under energized circuits, minimizing the risk of electrical injury. Adhering to the NEC requirements for water pipe bonding, including proper sizing of the bonding jumper and connection to the service equipment or grounding electrode system, is essential for ensuring electrical safety in buildings. The National Electrical Code, or NEC, is a comprehensive set of standards and guidelines for safe electrical installations. It is updated every 3 years by the National Fire Protection Association, or NFPA, to reflect the latest advancements in electrical technology and safety practices. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and bonding. It is widely adopted by jurisdictions throughout the United States and serves as a benchmark for electrical safety worldwide. Several key sections of the NEC are particularly relevant to water pipe bonding. Section 250.4 outlines the general requirements for grounding and bonding, emphasizing the importance of creating a low impedance path for fault current to flow back to the source. Section 250.50 covers the grounding electrode system, specifying the types of grounding electrodes that are permitted and how they must be installed. Section 250.52 details the requirements for specific types of grounding electrodes, such as ground rods, ground plates, and metal water pipes. Section 250.66 provides the table for sizing the grounding electrode conductor, including the water pipe bonding jumper, based on the size of the service entrance conductors. Water pipe electrodes must be supplemented by an additional electrode, such as a ground rod or ground ring. This is due to concerns about the reliability of water pipes as grounding electrodes, as they can be subject to corrosion, repairs, or replacement with non-conductive materials. The supplemental electrode provides a backup grounding path in case the water pipe electrode becomes ineffective. Now let's review the steps involved in performing a water pipe bonding. Firstly, identify the metal water piping system. Locate the point where the metal water pipe enters the building and identify any other accessible metal water pipes within the building. Secondly, select the appropriate bonding jumper. Choose a bonding jumper of the correct size, as determined by NEC 250.66, based on the size of the service entrance conductors. The bonding jumper should be made of copper or other approved conductive material and should be long enough to reach from the water pipe to the service equipment or grounding electrode system. Thirdly, prepare the bonding surfaces. Clean the surfaces of the water pipe and the service equipment or grounding electrode system where the bonding jumper will be connected. Remove any rust, paint, or other non-conductive coatings to ensure a good electrical connection. Fourthly, install the bonding jumper. Connect the bonding jumper to the water pipe using a listed bonding clamp or fitting. Ensure that the clamp is securely fastened to the pipe and that it makes good electrical contact. Connect the other end of the bonding jumper to the service equipment enclosure or to the grounding electrode system using a listed lug or connector. Fifthly, inspect the bonding connection. Visually inspect the bonding connection to ensure that it is secure and that all connections are tight. Use a multimeter to verify that there is a low impedance path between the water pipe and the service equipment or grounding electrode system. Water pipe bonding serves as an important role in electrical safety by providing a low impedance path for fault current, protecting against electrical shock hazards, and ensuring proper operation of overcurrent protective devices. Adhering to the NEC requirements for water pipe bonding is essential for all electrical installations. The NEC requirements for water pipe bonding are designed to ensure electrical safety and protect against shock hazards. These requirements cover various aspects of water pipe bonding, including the size and material of the bonding jumper, the location of the bonding connection, and the coordination with the grounding electrode system. Understanding these requirements is crucial for electrical contractors, inspectors, and anyone involved in electrical installations. The effectiveness of water pipe bonding depends on several factors, including the quality of the bonding connection, the size and material of the bonding jumper, and the condition of the water piping system. A loose or corroded bonding connection can significantly increase the impedance of the grounding path, reducing its effectiveness in dissipating fault current. Similarly, a bonding jumper that is too small or made of an unsuitable material may not be able to safely carry the maximum fault current. The condition of the water piping system is also important, as corroded or damaged pipes may not provide a reliable grounding path. Regular inspection and maintenance of water pipe bonding connections are essential for ensuring their continued effectiveness. Bonding connections should be visually inspected for signs of corrosion, damage, or looseness. If any problems are found, the connection should be cleaned, repaired, or replaced as necessary. The impedance of the grounding path should also be periodically tested using a multimeter to verify that it remains within acceptable limits. By following these maintenance practices, you can help ensure that water pipe bonding continues to provide effective protection against electrical shock hazards. When performing water pipe bonding, it is important to follow all applicable safety precautions to protect yourself from electrical hazards. Always de-energize the circuit before working on any electrical equipment or wiring. Use insulated tools and wear appropriate personal protective equipment, such as rubber gloves and safety glasses. If you are not comfortable working with electricity, it is best to hire a qualified electrical contractor to perform the water pipe bonding. In addition to water pipe bonding, there are other bonding and grounding techniques that can be used to enhance electrical safety. Equipment grounding conductors, or EGs, are used to ground the non-current carrying metal parts of electrical equipment, such as appliances, tools, and machinery. Bonding jumpers are used to connect metal enclosures, raceways, and other metal parts to create an electrically continuous grounding path. Ground fault circuit interrupters, or GFCIs, are used to protect against electrical shock hazards by detecting ground faults and interrupting the circuit. Surge protective devices, or SPDs, are used to protect against voltage surges caused by lightning or other electrical disturbances. By using a combination of these bonding and grounding techniques, you can create a comprehensive electrical safety system that protects against a wide range of hazards. Water pipe bonding is a critical component of a comprehensive electrical safety system. By understanding the NEC requirements for water pipe bonding, following proper installation and maintenance practices, and taking appropriate safety precautions, you can help ensure that your electrical system is safe and reliable. Water pipe bonding is a crucial aspect of electrical safety that is often overlooked. It involves connecting the metal water piping system of a building to the electrical grounding system to create a low impedance path for fault current. This bonding helps to protect against electrical shock hazards and ensures the proper operation of overcurrent protective devices. The NEC provides detailed requirements for water pipe bonding, including the size and material of the bonding jumper, the location of the bonding connection, and the coordination with the grounding electrode system. Understanding these requirements is essential for electrical contractors, inspectors, and anyone involved in electrical installations. By following the NEC guidelines and implementing proper water pipe bonding techniques, you can help to create a safer electrical environment for yourself and others.